Good morning, Earth Science. It's time to talk about Sunpaths. I know you've been waiting to hear about this all week because you have a packet called Sunpath Lab. So I won't let you wait. I'm going to start talking about sunpaths right away. All right, what is a sunpath? A sunpath is the path that the sun appears to take in the sky. And I'm going to say appear because we know that the sun really doesn't rise on its own and sets on its own. That would, if you believe that, you would be more of a flat earther that thinks that, yeah, the sun does have a motion of its own. But we know in science that the sun doesn't really rise in the sky. The sun just stays there. What's moving is the earth. The earth moves around the sun in a motion that we're going to call revolution, remember? Revolution. And the earth also spins on its own axis, causing day and night, and that's called a rotation. And when we see the sun rise above at noontime and set, that is due to a motion called a rotation. The earth rotates on its axis, making the sun appear to rise and then set. So that's what I'm going to draw on this diagram right here. On this diagram, I have a very happy person in the middle of the ground. This is kind of the ground right here. I've labeled these coordinates east, west, north, and south. So if I were looking this way, I would see north. If I were looking this way, east, south, west, etc. And this right here, this is my dome. This is like the sky that I'm seeing above me because the earth is round. And I'm going to portray that as a round dome. So what I'm seeing right here, I'm going to see the sun rising somewhere in the east. Let's put it directly east to start off with. I'm going to see a sun rising in the east. Maybe I'll put this in another color even. And then the sun is going to appear to rise above at noon and sets in the west. So that this thing that I drew right here, this is called a sunpath. Now, a lot of concepts to know about sunpath is that the sun doesn't always rise directly in the east. What? You were taught the sun rises in the east? Well, good for you. Well, the sun can rise sometimes a little bit in the south, a little bit in the north, but it generally is in the eastern direction, okay? It's not exactly east. In fact, it's only exactly east twice a year. It's only exactly east on March 21st and September 21st, which we learned is the spring equinox and the fall, I'm writing sideways, equinox. And that's when equal night, that's when the earth has 12 hours daylight, 12 hours nighttime. And that's also when the sun is exactly east, exactly west. Not always exactly above us, but I'm going to get to that. That depends on your latitude. But this is the general concept of sunpath. Now, we're going to talk about something called latitude. So I'm going to draw another earth here. Earth. And remember that latitude are these imaginary lines that cut the earth that run parallel to the equator. And the equator is here, and we're going to call this 0 degrees latitude, remember? And I'm going to say that at the top here is 90 degrees north, and at the bottom is 90 degrees south. And in the middle, I'm going to have 45 degrees south and 45 degrees north, okay? And remember that I said in a previous video that the earth is tilted at an angle of 23.5 degrees, and I said that that number was going to become really important later on. Well, it's important now. It's important now because this tilt of the earth means that there are two other places on earth where the sun can be directly overhead, and they are called the Tropic of Cancer and Tropic of Capricorn. Tropic of Cancer and Tropic of Capricorn. And what those two places are, I'm going to draw another earth here. Those are two latitudes where the tilt of the earth allows the sun to be directly overhead at these two places. And in any place in between these two places, the sun can be directly overhead. 23.5 degrees north is the Tropic of Cancer, and 23.5 degrees south is the Tropic of Capricorn. All right, so let's start off by talking about the equator. I'm going to erase this image and replace it by an image of the equator. Okay, to help me in my diagram, I have Mr. Ducky. Mr. Ducky is a graduating ducky, the class of 2020. And right now, he's going to help me by being in the center of my diagram, and I have a glass bowl above him. And I'm going to pretend that Mr. Ducky is looking at the sun. Mr. Ducky, right now, is on the equator. What that means for Mr. Ducky is that the sun is almost directly overhead. So on March 21st, let's see if this is going to work. I'm going to have a sun that rises here in the east, travels above Mr. Ducky directly overhead, like that, and comes all the way over here in the west and sets. And it's directly overhead, east, overhead, west. Okay? Now, in one of your problems in your packet, you will have a sun path like this with some numbers and letters on them. So if you have a sun that's over here, what time do you think the sun could represent? It's rising. It's in the east. I'm going to label this with an E. Probably won't be able to see that. Oh, there you go. Labeled it E. Okay. So this time over here could be, let's say 6 a.m. So I'm going to label here 6 a.m. Now, if the sun were here, what could a possible time for this sun be? It's not directly overhead yet. It's not above Mr. Ducky. It's halfway between 6 a.m. and I'm going to say noon, 12 p.m. So this sun right here could be 9 a.m. So we have 6 a.m., 9 a.m., 12 p.m. All right, continuing on our sun path. Let's say that the sun sets at 6 p.m. so that we have a perfect day. That's a 12-hour day that the sun starts off at 6 a.m., sets at 6 p.m., and halfway is noon. So if I have a sun right here, halfway between 12 noon and 6 p.m., what time could this be? Well, halfway would put us at 3 p.m. Okay. Oh, Mr. Ducky fell. Sorry, Mr. Ducky. Okay, Mr. Ducky's back. All right, so that is an example of what would happen at the equator. Now, this type of thing happens in New York, but I'm going to start off with the equator because the equator is slightly easier to understand. The sun that rises directly in the east and sets directly in the west, we said happens two days in a year, March 21st and September 21st, the equinoxes. If, on the equator, if it is June 21st, which is a solstice, what would happen to my sun? Well, I'm going to label here. I'm labeling this glass bowl. This is north, and over here is south. Well, on June 21st, the Earth is tilted towards the sun on June 21st in the northern hemisphere. So the sun on the equator, Mr. Ducky's going to see that the sun is slightly to the north because the Earth is tilted in the northern hemisphere towards the sun. So the sun is going to appear to be slightly rising. I mean slightly. It's not in the north. It's just slightly north of due east. That's how we say it in science, north of due east. And I'm going to put a sun right here where you can see it. Can you see that? Maybe you can see that. Okay, so I have a sun here, and it's going to rise. Now, it's not directly above Mr. Ducky at noon anymore. It's a little still to the north, but this is still 12 p.m. And then it's going to set over here in the west at 6 p.m. still. But now the sun path, the second sun path that I drew, is not directly above Mr. Ducky. It's a little bit to the north because this is a sun path that happens on June 21st. On June 21st. I'm going to draw the next one in a different color so you can see it better. In December, the sun is tilted away from the Earth is tilted away from the sun in December. So what happens is that now the sun is going to appear to rise slightly south of due east. And it's going to go... I killed Mr. Ducky again. He just does not want to stay there. I'll get him later. It's going to appear to rise south of due east. Noon is going to be south of due east, and it's going to set also south of due west. So my third sun path would look like this. Now, these scenarios that I wrote down here, this is good for the equator, okay? This is good for the equator. Not everywhere on Earth is going to have these sun paths. In fact, they're going to look very different, especially in the northern hemisphere. I'm going to rescue Mr. Ducky and I'll be back. Now, if I were to draw on the whiteboard what I just did with my glass bowl over Mr. Ducky, this is what it would look like. I would have a ground with a person or a duck, a glass dome, or like an imaginary dome over this person, and this is how I would label the sun path. I would put east, south, west, north, and I would have something like, oops, this is slightly off, it needs to be directly. This is what would happen on March 21st or September. So fall or spring. This is what would happen in the summer because it's slightly north. So this is what would happen on June 21st. And I'm going to start up a little bit in the eastern part. This is what would happen on December 21st. Okay, so I have 3 sun paths. 3 times that the sun appears to change its position in the sky because the earth is revolving around the sun and the tilt of the earth changes, making the sun appear to be higher or lower in the sky. That's it for today. I'm just going to stop here on this example of the equator. This does not represent what happens in the Tropic of Capricorn or the Tropic of Cancer or the North Pole or even New York. So don't get ahead of yourselves. I just want everybody to understand this concept. And if you don't understand this concept, please email me or ask me during Zoom. I look forward to seeing you all at 10 a.m.